First property, n factorial, it is nothing but n into n minus 1 into n minus 2 and so on up to 3 into 2 into 1. So factorial is nothing but product of all consecutive natural numbers from n to 1. From n to 1. Next key point, 0 factorial, it is nothing but 1. 0 factorial, it is nothing but 1. If I want 4 factorial, which is 4 into 3 into 2 into 1, which is nothing but 24. If I want 6 factorial, it is nothing but 6 into 5 into 4 into 3 into 2 into 1. 5 into 4 into 3 into 2 into 1. It is called 5 factorial. Another important property, n factorial, it is given by n into n minus 1 factorial. N factorial, it is given by n into n minus 1 factorial. I hope the idea it is clear. Next one, ordered pair. Ordered pair and unordered pair. Ordered pair. And next is an unordered pair. In an ordered pair, order in which you write the variables matters. Order matters. Order in which you write the variables matters. That means a comma b and b comma a. In a comma b, the first variable it is a. In b comma a, the first variable it is nothing but b. Both are different. Ordered pair, right order in which you write the variables matters. In unordered pair, order does not matter. Order does not matter. Order does not matter. That means a into b is equivalent to b into a. A into b is nothing but equivalent to b into a. Order matters. That means, for example, I want 10 students in an height in an ascending order. Order matters. I want the weight of all the students starting from 20 kgs till 70 kgs. Order matters. So whenever there is a condition imposed in an problem, whenever there is a condition imposed in a problem, I will use ordered pair. Ordered pair, it is nothing but combinations. Ordered pair, it is nothing but combination. Order matters. Order matters. Unordered pair. Unordered pair means order does not matter. So in whatever the way that can be written, it can be right. Permutations. Permutations is used for unordered pair. Combinations is used for an ordered pair. Combinations, it is used for an ordered pair. Combinations, it is for ordered, or in other words, in a mathematical arrangement, there is 3 people have to be arranged. There is no order. First person can be 1, 2 or 3. Second person can be 1, 2 or 3. Third person can be 1, 2 or 3. If there is any condition imposed on a problem, I will use selection. In selection, I will use combinations. I will use combinations. Ordered pair and an unordered pair. Ordered pair and an unordered pair. All the problems what we are solving today are based on condition related problems. Fifth one, NPR, it is nothing but n factorial by n minus r factorial. NPR, it is nothing but n factorial by n minus r factorial. Suppose there is a 3-digit number that needs to be formed using the digits 1, 2, 3 and so on up to n. 1, 2, 3 and so on up to n. I want a 3-digit number. I want a 3-digit number. So there is no restriction on leftmost or the rightmost place. This place it can be 9. This place it can be 8. This place it can be 7. This can be written as 9 into 8 into 7. I will multiply and divide with 6 factorial in the numerator and the denominator. 6 into 5 and so on up to 1. These is nothing but 9 factorial by 6 factorial. 9 factorial. These is also nothing but 9 factorial by 9 minus 3 factorial. That is the reason NPR it is given by n factorial by n minus r factorial. NPR it is given by n factorial by n minus r factorial. Second, If it is NP0, NPR is n factorial by n minus r factorial, which is nothing but 1 out of n arranging 0. Arranging 0 elements out of n elements, it is nothing but 1. Second one, NPN. NPN, it is nothing but n factorial by n minus n factorial. N factorial by 0 factorial, it is 1. So NPN, it is nothing but 1. NPN, it is nothing but 1. NPR is defined by n factorial by n minus r factorial. N factorial by n minus r factorial. So NP0 it is 1, NPN it is 1. Why am I doing all this? You will understand once we are solving problems. Eighth one, suppose if it is NCR, it is there. Suppose I want a 3-digit number. I want a 3-digit number. From the digits 1, 2, 3 and so on up to 9. There are 9 digits, 1, 2, 3 and so on up to 9. I want a 3-digit number. I want a 3-digit number. So these first digit can be taken by any one out of the 9 digits. Second digit, any one out of the 8 digits. It is third digit, any one out of the 7 digits. Repetition of the digits is not allowed. Repetition of the digit C is not allowed. If the repetition of the digit C is not allowed, then it is 9 into 8 into 7. 9 into 8 into 7. Suppose there is a condition that is imposed. There is a condition that is imposed on a 3-digit number. What is the condition that is imposed on the 3-digit number? Hundreds place. Hundreds place is greater than tens place is greater than units place. Hundreds place greater than tens place greater than units place. There is a condition that is imposed on a question. These 3 places can arrange among themselves in 3 factorial. There will be one way where the numbers will be in ascending order. There will be also be one way where they will be in descending order. So total number of 3-digit numbers are nothing but 9 into 8 into 7. These 3 numbers can arrange among themselves in 3 factorial. If 3 numbers are there, visualize any 3 numbers that comes into your mind. There will be only in one way where they will be in ascending order. There will be only one way where there will be in descending order. So these nothing but 9 into 8 into 7 into 6 factorial divided by 6 factorial into 1 by 3 factorial. These are nothing but 9p3. 9p3 by 3 factorial. Are you all with me? 9p3 is 9 factorial by 9 minus 3 factorial, which is 6 factorial. 9 into 8 into 7 into 6 into 6 factorial, it is nothing but 9 factorial. These are nothing but 9 factorial by 3 factorial and 6 factorial. Extremely important key point. NCR, it is nothing but total number of arrangement of R objects in out of N objects. R objects can arrange among themselves in R factorial. NCR, it is nothing but NPR by R factorial. NPR by R factorial. I hope it is clear. R, in other words, NPR, it is nothing but NCR into R factorial. NCR into R factorial. Here there are order matters. Here order does not matter. 1, 2, 3 can also be written as 3, 2, 1. So order does not matter. Obviously NPR will be equivalent to NCR into R factorial. Extremely important key point. NPR equivalent to NCR into R factorial. Whenever there are conditions imposed in the problem, use NCR. When there are no conditions imposed on the problem, use NPR. For example, in a 3-digit number, hundreds place less than tens place less than units place. Hundreds less than tens less than units. There is a condition. So use NCR. If there are conditions, use NCR. If there are no conditions, use NPR. NPR equivalent to NCR into R factorial. Another important key point, ordered pair means use NCR. Order does not matter. Think logically. One is order matters, another is order does not matter. That means reverse also can come. Obviously, NPR is nothing but first write down the order, and these orders can arrange among themselves in R factorial. So NPR equivalent to NCR into R factorial. NCR, it is nothing but NPR into R factorial. Next one, ninth one. Another important property, NC is 0. Suppose there are n students sitting in class. I am not selecting any student. I am not selecting any student. There is only one way. I entered into the class. I said, how many students got greater than 95 percentile? None of the students got greater than 95 percentile. And I left the class without selecting any student. I went, made an announcement, not selected any, and came out. NC 0, it is nothing but 1. Out of n students, selecting all students, I entered into the class and I said, today we are not conducting the class. And I said, everybody let us go to park. There is only one way. Selecting entire n out of n. Selecting all the students out of all the students. It is nothing but 1. Next one. NCR, suppose out of 5 I am selecting 2. Out of 5 students I am selecting 2. It is nothing but rejecting 3. Out of 5 rejecting 3, it is also nothing but selecting 2. NCR, it is nothing but equivalent to NCN minus R. It is nothing but NCN minus R. NC 0 equivalent to 1, NCN equivalent to 1, NCR equivalent to NCN minus R. Another important property is sum of all the coefficients, not selecting any, selecting 1, selecting 2, and so on up to selecting n. It is given by 2 power n. NC0 plus NC1 plus NC2 and so on up to NCN, it is given by 2 power n. For example, 4C0 plus 4C1 plus 4C2 plus 4C3 plus 4C4, 4C4. 4C0, out of 4 not selecting any, out of 4 selecting 1, it could be first or second or third or fourth. 4C2, it is 6, out of 4 selecting 3, that means rejecting 1. 4C1, it is 4, out of 4 selecting 4, this is nothing but 16, so it is nothing but 2 power 4. 4C0 plus 4C1 plus 4C2 till 4C4. Answer is nothing but 2 power 4. Very, very important properties. Today in the class, we are discussing good number of property related problems. 13th one. Sum of even NC0 plus NC2 plus NC4. It is nothing but 2 power n minus 1. It is nothing but 2 power n minus 1 till NCN. Taking even numbers. For example, 4C0 plus 4C2 plus 4C4. These is nothing but 1. These is 6 and it is 8. So 3 it is there. So it is nothing but 2 power 4C0 plus 4C2 plus 4C4. Even it is nothing but 2 power 4 minus 1. It is 8. Odd, it is nothing but NC1, NC3 and so on and so on. It is again nothing but 2 power n minus 1. NC0 plus NC1 plus NC2 till NCN is 2 power n. Selecting 0, selecting 1, selecting 2, selecting 3, selecting n. Sum of all these, it is given by 2 power n. Selecting only not and even values, it is nothing but 2 power n minus 1. Odd, it is nothing but 2 power n minus 1. 2 power n minus 1. 15th one. 15th one. NCR by NCR minus 1. It is given by n minus r plus 1 by r. NCR by NCR minus 1. It is nothing but NCR minus 1. How you got this one? NCR, it is nothing but n factorial by n minus r factorial by r factorial. If divided by n factorial, it is nothing but n minus r, n minus of r minus 1, n minus r plus 1 factorial into r minus 1 factorial. These both will be cancelled. These are nothing but n minus r plus 1 factorial into r minus 1 factorial divided by n minus r factorial into r factorial. So these are nothing but n minus r plus 1. N factorial is n into n minus 1 factorial into n minus 1 factorial into divided by n minus r factorial. R factorial is r into r minus 1 factorial. R minus 1 factorial. These both will be cancelled. These both will be cancelled. NCR by NCR minus 1. It is given by n minus r plus 1. NCR by NCR minus 1. It is given by n minus r plus 1 by r. N minus r plus 1 by r. Suppose if NCR minus 1 is A. NCR it is nothing but B. NCR plus 1 it is nothing but C. R is nothing but A into B plus C divided by B square minus AC. In case if you cannot remember it, you can go by the generic calculation by dividing NCR by NCR. R is nothing but A into B plus C by B square minus AC. There was one direct questions based upon this identity. NCR by NCR minus 1, it is nothing but N minus R plus 1 by R. 17th property is extremely important. What is that property? NCR is maximum. NCR is maximum only when NCR is maximum only when R is nothing but n by 2. If n is even, if n is even, if n is odd, if n is an odd number, NCR is maximum only when R is n minus 1 by 2 or n plus 1 by 2. Very, very important. There were some exam model questions which came based upon this concept. NCR is maximum only when R equivalent to n by 2 or R equivalent to n minus 1 by 2 or n plus 1 by 2. Example. 17 CR is maximum. 17 CR it is maximum. When it will be maximum? When R equivalent to n minus 1 by 2 or n plus 1 by 2. Both will be same in terms of value. So R is nothing but 8 or 9. If I substitute 8, 17 C8, out of 17 selecting 8, it is also nothing but rejecting 9. So both will be same. NCR it is maximum only when R equivalent to n by 2 if n is even, or R equivalent to n minus 1 by 2 or n plus 1 by 2. One is when n is even, another is when n is odd. N is even, R equivalent to n by 2. N is odd, n minus 1 by 2 or n plus 1 by 2. Another last property, right? NCR plus NCR minus 1. It is nothing but n plus 1 CR. NCR plus NCR minus 1. It is nothing but n plus 1 CR. Very, very important property. For example, 4C2 plus 4C1. 4C2 plus 4C1. 4C2 it is nothing but 6. 4C1 it is nothing but 4. 6 plus 4 it is 10. So it is equivalent to n plus 1 CR. 4 plus 1 C2. Directly it is nothing but 5C2. Directly it is nothing but 5C2. Directly it is nothing but 5C2. Where it is used? In your examination, this question was asked 8C4 plus 8C3. 8C3 plus 9C5. These nothing but plus 10C6 equivalent to 8C4 plus 8C3 plus 9C4 plus 10C6 equivalent to. Now if you observe NCR plus NCR minus 1, it is n plus 1 CR. 8 plus 1 9. 9 it is nothing but 9C4 plus 9C5 plus 9C5 plus 9C6. NCR plus NCR minus 1. Again it is nothing but N plus 1 CR, which is nothing but 10C5. 10C6 plus 10C5, which is nothing but 11C6. Answer is directly 11C6. Please write down, sir. NCR plus NCR minus 1. These is nothing but equivalent to N plus 1 CR, N plus 1 CR, 18 properties. These 18 properties are extremely important to solve some of the problems where there was an execution of a property. All 18 problems, I hope the idea it is clear. 18 problems. Now we'll solve a lot of problems based on property. In your examination, there will be some questions based on property. First one, summation n equivalent to summation. The question is summation r equivalent to 1 to n, 1 to n, npr by r factorial. npr by r factorial. Already we have seen it is nothing but ncr. It is nothing but NCR. R is starting from 1, NC1, next it is NC2, and so on up to NCN. Just now we have seen in the property NC0 plus NC1 plus NC2 till NCN. It is nothing but 2 power n. This is missing. So answer is nothing but 2 power n minus 1. 2 power n minus 1. First one answer is nothing but 2 power n minus 1. This is method number 1. This is method number 1. This is method number 1. In case if you forgot the property, substitute a values. Substitute values. If the question contains variables, answer contains variables. Substitute the values. Suppose for example, n is nothing but 3 it is there. If it is n is 3, the question will become r equivalent to 1 to 3. It is 3cr, which is nothing but 3c1 plus 3c2 plus 3c3. 3c1 it is nothing but 3. 3c2 it is nothing but 3. 3c3 it is 1. Answer is 7. I substituted n equivalent to 3. Which value when n equivalent to 3 will give you 7? 2 power 3 minus 1. 8 minus 1, the value is nothing but 7. Value is nothing but 7. One needs to know this property. Another is substitute the values method. Substituting the values method, at times it is very, very easy in case if you cannot remember that property. I hope question number 1, it is clear to you. Question number 2. If, okay, another important property which we discussed yesterday. What is that property? If NCR is equivalent to NCS, there are two cases. Either R equivalent to S or R plus S equivalent to N. If NCR is equivalent to NCS, either R equivalent to S or R plus S equivalent to N. How it is formed? Suppose, for example, NC, R it is there. Selecting R, it is nothing but rejecting N minus R. This sum is nothing but equivalent to N. 4 and 12 are not equal. So, N is nothing but 4 plus 12, which is nothing but 16. 16C2. 16C2. NC2, it is nothing but N into N minus 1 by 2. N into N minus 1 by 2. 16 into 15 by 2, which is nothing but 120. Which is nothing but 120. I hope the idea it is clear. Now, if you see here, what you can do is, you can also play around with answer option. 15, what are the prime factors? 3 and 5. Answer should be divisible by 5. Any number divisible by 5, unit digit should be 0 or 5. So, 156, 78, it is just directly out just by taking the prime factors of 15. Prime factors of 15. I hope the idea it is clear. NCR equivalent to NCS. Either R equivalent to S or R plus S equivalent to N. Another exam model question. r plus s equivalent to n, r plus r 4 equivalent to 20, 2r is nothing but 16, r is nothing but 8, r is nothing but 8, which is nothing but 8c3. 8c3 means start from 8, write down 3 consecutive, start from 3, write down 3 consecutive decreasing value. These is nothing but 8 sevens are 56. It is nothing but 8 sevens are 56. Another way to look at it is 8c3. 8 is a composite number. What is the prime number just less than 8? 7. Answer should be divisible by 7. Answer should be divisible by 7. Answer should be divisible by 7. So 8 sevens are 56. 336 is 56 into 6. It is getting into an higher value. Answer is 56. Larger numbers, these logic will be extremely useful. 16cn, the value of 16cn divided by 17cm. When numerator and denominator both have greatest value, when it will be greatest value? When n equivalent to r by 2. So n is nothing but 8. This value is 16c8. When r equivalent to n minus 1 by 2 or n plus 1 by 2, which is 16 by 2, it is 8, which is nothing but 17c8. 17c8. 16c8 by 17c8. These is nothing but 16 factorial by 17 8 factorial, 8 factorial, 17 factorial by 9 factorial and 8 factorial. These will be cancelled. So 16 factorial by 8 factorial into 9 factorial by 17 factorial. 17, it is 17 into 16. Denominator 17 will come, numerator 9 will come. Answer is 9 by 17. 9 by 17. Or you can see in the denominator 17 is a prime number. Denominator should contain 17. Just by looking at a question, 1 and 9 by 16, they both are eliminated. What is the concept that I used here? This is a property based problem. NCR, it is maximum. When it will be maximum? When r equivalent to n by 2 or r equivalent to n minus 1 by 2 or n plus 1 by 2. N minus 1 by 2 or n plus 1 by 2. First is used when n is an even number. Second is used when n is an odd number. N is an odd number. I hope the idea it is clear. Property based question. Third one. Next one. 9PR. 9PR. It is nothing but 504. 504. The value of R. Let me go by the answer option. First option 3. 9p3, it is nothing but 504. 9 factorial by 6 factorial into 3 factorial. It is nothing but 9 into 8 into 7 divided by 6. 6 12s are 9 factorial by 6 factorial. Sorry, this 3 factorial won't come. It is NPR. This kind of mistakes, don't do it, sir. So it is nothing but 9p3, 9p3, NPR, it is nothing but n factorial by n minus r factorial, 9 factorial by 6 factorial, which is nothing but 504. Let us check it out. 9 into 8 into 7 into 6 factorial by 6 factorial. 72 7s are 504. So answer is 1. Go by the answer options. Go by the answer options. Go by the answer options. I hope it is clear. Next one. Now, these based upon this one CAT question, original CAT question came. Summation r equivalent to 1 into 2, r into r factorial. You can solve this problem in multiple methods. Method number 1. Optimization method. One is optimization method. What is optimization method? Listen carefully. Question is summation is till 12. All the options are 13 factorial. I will forget about 12. I will take it as 3. So these is nothing but r into r factorial. These is nothing but 1 into 1 factorial, 2 into 2 factorial, 3 into 3 factorial. Are you all with me? So I took till 3. 1 factorial, it is 1. 2 2s are 4. 6 3s are, it is 18, which is nothing but 23. 23, it is nothing but 4 factorial minus 1. 4 factorial is 24. 24 minus 1 is 23. If I took till 3, I got the answer as 4 factorial minus 1. If I took till 5, I will get 6 factorial minus 1. 12, if I take, answer is nothing but 13 factorial minus 1. Answer is nothing but 13 factorial minus 1. Right? This is nothing but taking a smaller values and understanding the pattern. Taking a smaller values and understanding the pattern. I took till 3. I got the answer as 4 factorial minus 1. I took till 12. Answer will be 13 factorial minus 1. This is method number 1. Method number 2. Method number 2. How you got R? This is nothing but R equivalent to 1 to 12. R can be written as R plus 1 minus 1 into R factorial. R I wrote it as R plus 1 minus 1. So these is nothing but summation R equivalent to 1 to 12. R plus 1 into R factorial, which is R plus 1 factorial minus R factorial. R equivalent to 1. 1 plus 1 is 2. 2 factorial minus 1 factorial. R equivalent to 2. 3 factorial minus 2 factorial. R equivalent to 3. 4 factorial minus 3 factorial. R equivalent to 12. 13 factorial minus 12 factorial. Every negative has got a positive before. Every negative has got a positive before except minus 1 factorial. Answer is nothing but 13 factorial minus 1. Answer is nothing but 13 factorial minus 1. Writing down R as R plus 1 minus 1. Writing down R as R plus 1 minus 1. Based upon this logic, a original CAT question is developed. That also we will see it. R equivalent to 1 to 12, R into R factorial. R can be written as R plus 1 minus 1 into R factorial. R plus 1 into R factorial is R plus 1 factorial minus R factorial. Keep on substituting the values. R value 1, R value 2, R value 3, R value 2. 2 factorial minus 2 factorial, 3 factorial minus 3 factorial, plus 4 factorial minus 4 factorial. Last remaining is 13 factorial minus 1. 13 factorial minus 1. Right? Let us see the original CAT question which came. Please take down that question. Question is P is nothing but 1 into 1 factorial, 2 into 2 factorial, and so on up to 10 into 10 factorial. Reminder 1. Reminder 1. P plus 2 is divided by 11 factorial. P plus 2 is divided by 11 factorial. This is an original CAT question. This is an original CAT question. P is 1 into 1 factorial, 2 into 2 factorial, 10 into 10 factorial, and it goes on till P plus 2 divided by 11 factorial. You can solve this problem in two methods. Method number 1. Just now we have seen P 1 into 1 factorial, 2 into 2 factorial, and so on up to 10 into 10 factorial. This is nothing but summation R into R factorial. This is nothing but R plus 1 factorial minus 1, which we have seen. R equivalent to 1 to R. This is nothing but 10 plus 1, 11 factorial minus 1. So answer is nothing but reminder 11 factorial minus 1 plus 2 divided by 11 factorial. This is nothing but 11 factorial. 2 minus 1 is 1 divided by 11 factorial. This is perfectly divisible. Answer is nothing but 1. Answer is nothing but 1. Method number 1. Method number 1. I hope the idea it is clear. This is the exact CAT question that was asked, and it is based upon this concept, summation r into r factorial. Summation r into r factorial. This is method number 1. If you can write r as r plus 1 minus 1, you got the answer quickly. In case if you forget it, go by the method which I told, pattern recognition method. What is pattern recognition method? Method number 2. Method number 2. Question is like this. 1 into 1 factorial, 2 into 2 factorial, and so on up to 10 into 10 factorial. These is nothing but reminder p plus 2 divided by 11 factorial. P plus 2 divided by 11 factorial. See here. Take some smaller values. 1 factorial plus 2 into 2 factorial, right? If it is ending at 10 factorial, remainder is 11 factorial. Ending at 2 factorial, remainder will be 1 factorial plus 2 into 2 factorial plus 2 divided by which factorial? 3 factorial. If you take smaller values, you will get the answer quickly. These 1, 2 2s are 4 plus 2 divided by 6. 7 divided by 6. What is the answer for the question? 1. Either you can optimize the values or you can understand the behavior of the graph. Very, very important model, sir. R into R factorial. For this question, answer is 13 factorial minus 1. We have understood two methods and then we solved the CAT question. This optimization method is extremely important. Please take one more example. One more example. This is again a CAT question. R is 30 power 65 minus 29 power 65 divided by 30 power 64 plus 29 power 64. What is the R is less than 0.2, 0.3 less than R less than 0.7, R is from 0.8 less than, R is less than 1, D is nothing but R is greater than 1. R is greater than 1. 30 power 65 minus 29 power 65 divided by 30 power 64 plus 29 power 64. Which of the four options it is always true? Which of the four options it is always true? How students will solve it? Method number 1. Method number 1. A cube minus B cube is A minus B into A square plus B square plus AB. A square plus B square plus AB. So, these is nothing but, if you observe closely, 30 power 65 minus 29 power 65. These is nothing but 30 minus 29 into 30 power 64 plus 29 power 64. If it is 3, in the second term it is 2. If it is 65, 30 power plus some positive value. Plus some positive value. I hope you are all there with me. 30 power 65 minus 29 power 65 divided by 30 power 64 plus 29 power 64. These divided by this value. 1 plus positive. Answer is nothing but greater than 1. Are you all with me? 30 power 64 plus 29 power 64 plus and so on divided by 30 power 64 plus 29 power 64. So, this divided by this it will be 1. 1 plus positive it is nothing but greater than 1. It is one way of doing it. A cube minus B cube is A minus B into A square plus B square plus AB. 30 power 65 minus 29 power 65 is 30 minus 29 into 30 power 64 plus 29 power 64 plus positive. These divided by this value. 1 plus positive, answer is greater than 1. Now, how I solved in the examination is, how I looked at this question is, this generic method it is okay, right? Now, how my student should solve it? Assume that the option is D. So, if it is D, 30 power 65 minus 29 power 65. It is greater than 30 power 64 plus 29 power 64. These is nothing but 30 power 65 minus 30 power 64. It is greater than 29 power 64 plus 29 power 65. 30 power 64 common. 30 minus 1, which is 29. 29 power 64 common. 1 plus 29, 30, which is nothing but 30 power 63. It is greater than 29 power 63. If the power is a natural number, 30 is greater than 29, that means my assumption is right. If I take r greater than 1, I got this property. That means 30 power 63, it is greater than 29 power 63. That means my assumption of fourth option, it is right. It is like mathematical induction. You will take n equivalent to 1. You will take n equivalent to k. And you will prove that this thesis works for k plus 1. So therefore the theorem, right, it is proved. Same concept. Take r greater than 1 and check it out whether left hand side is greater than right hand side. Yes, it is possible. I hope you have understood how you can look at it from an optimization point of view, how you can look at it from a pattern point of view, or how you can probably look at it from the answer options. You can look at it from the answer options. I hope this idea it is clear. Now what I did is I shifted the question. So if that can be asked, why can't this can be asked? So same question, r equivalent to 1 to 12, r square, I am adding r and I am subtracting r into r minus 1 factorial. Just I created a new question so that this variety comes also, you will not fear it. The biggest role of my classes is to make you supremely confident by telling you that all that we have discussed in the class, r into r plus 1 minus r into r minus 1 factorial. These is nothing but r equivalent to 1 to 12, r plus 1, r plus 1 r. So n factorial, it is nothing but n into n minus 1 into n minus 2 factorial. This is one way. It can also be n into n minus 1 factorial. So these is nothing but r plus 1 factorial minus r factorial. Are you all with me? R plus 1, r minus 1. It is nothing but r plus 1 factorial. R into r minus 1 factorial. So 1 if I substitute, 2 factorial minus 1 factorial, 3 factorial minus 2 factorial, and so on up to 13 factorial minus 12 factorial. All negatives will get cancelled except minus 1. Answer is nothing but 13 factorial minus 1. This is method number 1. Method number 1. R equivalent to 1 to 12. What I did, I added r and I subtracted r. Then I used the property of n factorial is n into n minus 1 into n minus 2 factorial, or it is n into n minus 1 factorial. In case if you forget these logic, what I told you, optimal approach, summation r equivalent to 1 to 3, r square into r minus 1 factorial, optimize it. This is nothing but 1 into 1 minus 1 factorial. Next it is 2 square into 2 minus 1 factorial. Next it is 3 square into 3 minus 1 factorial. These 1 minus 1 factorial, 0 factorial. 4 into 2 minus 1, it is 1. 3 square, it is 9. 3 minus 1, 2 factorial, it is 2. So these 1 and it is 4. It is 18, which is again 23, which is 4 factorial minus 1. 4 factorial minus 1. 3 I got 4 factorial minus 1. 12 I will get 13 factorial minus 1. In case that logic of adding r or subtracting r does not hit your mind, you can go by the optimization method. Kindly reply in the live chat if everything is clear to you. Right? Is everything clear to you? Is everything clear to you? I hope it is clear. Method 1 and method number 2. Here, n factorial whole factorial. Question contains variables. Question contains variables. Answer also contains variables. If the question contains variables, answer contains variables. The best method is substitution. The best method is substitution method. Best method is substitution. Substitute any value, you will come to know. N equivalent to 3. These is nothing but 3 factorial and factorial. 3 factorial is 6. 6 factorial, it is nothing but 720, which is 6 into 5 into 4 into 3 into 2 into 1. Now, first option number 1. These is nothing but 3 factorial power 3 factorial. 6 power 6. 6 power 6 will not divide 720. First one not possible. 3 factorial power 3 minus 1, 2 factorial. It is 6 square, 36. Here, does 36 divide 720? Yes. 720 is 36 into 20. 36 into 20. Answer is nothing but option B. Answer is nothing but option B. Remember this point. If the question contains variables, answer contains variables, substitution method is the best method. Substitution method is the best method. Next one. 63R, it is maximum. NCR is maximum only when R equivalent to n minus 1 by 2 or n plus 1 by 2. n minus 1 by 2 or n plus 1 by 2. R can be either 31 or 32. R can be 31 or 32. NCR, it is maximum concept. That is the reason I wrote the properties. NCR is maximum if R is nothing but n minus 1 by 2 or n plus 1 by 2 if n is an odd number. If n is an odd number. Property related question. NCR minus 1. So first I will give an idea. Divide NCR by NCR minus 1, which is nothing but n minus R plus 1 by R equivalent to 20 by 15. Next divide NCR plus 1 divided by NCR, which is nothing but 15 by 20. So solve these two equations, you will get it. Solve these two equations or you will get it. What is the another way? I already told you. R is nothing but A into B plus C divided by B square minus AC. A is 15. 15 into 20 plus 15, which is 35. B square. So 20 square minus 15 square. So these is nothing but 15 into 35. A square minus B square. A minus B into A plus B. 15 by 5. What will be the answer? 3. Answer is nothing but 3. What is that we discussed in the property? NCR minus 1 is A. NCR, it is nothing but B. NCR plus 1, it is nothing but C. R is nothing but A into B plus C divided by B square minus AC. Please make a note of it, sir. Very, very important. This conclusion can be drawn by doing 2 by 1 and 3 by 2. 2 by 1 and 3 by 2. Extremely important. NCR minus 1 is A. NCR, it is B. NCR plus 1, it is C. R is A into B plus C by B square minus AC. Next one. Another one. The number of positive integers. The number of positive integers satisfying the inequality. N plus 1. C n minus 2 minus n plus 1. C n minus 1 less than or equivalent to n. Less than or equivalent to n. Positive integers means it will start with 1. It will start with 1. The best way to solve is by using answer options. First option 6. 6 plus 1 is 7. 6 minus 2, it is nothing but 4. minus 6 plus 1, it is nothing but 7. C. 6 minus 1, which is nothing but 5, which is nothing but 5. I hope it is clear. N plus 1, C n minus 2. These is nothing but 7C4. 7C4, it is nothing but 7 into 6 into 5 into 4 divided by 4 into 3 into 2 into 1. These 4 cancel, 3 2s are cancel. These is nothing but 35. 7C5 is 7 into 6 by 2, which is 21. 35 minus 21 is 14. 14 is less than 100. 6 is satisfying. So, let me take this option as 5. 5. Let us take n value 9. Second option, n value 9. 9 plus 1. 9 plus 1, it is nothing but 10. 9 minus 2, it is nothing but 7. 9 plus 1, it is nothing but 10. 9 minus 1, which is nothing but 8. Less than or equivalent to 100. Let us see. 10C7 is 10 into 9 into 8 divided by 3 into 2 into 1 minus n into n minus 1 by 2. 6. These 12s are. So 12, 120. These nothing but 2 5s are, which is 45. 120 minus 45, which is nothing but 75. 75 is less than or equivalent to 100. Let me take 11 because just the value is just less than 100. If I take 11, what will be the answer? 11 plus 1 is 12. 11 minus 2, it is nothing but 9. Minus 11 plus 1, 12. 11 minus 1, it is 10. 12C9 is 12 into 11 into 10 divided by 3 into 2 into 1. These 12 into 11 by 2. 6. These 22. 22 means 220. 220 minus 66. It is not less than 100. That means n can take any value from 1 to 10. N can take any value from 1 to 10. N can take any value from 1 to 10. I hope it is clear. So, n value, I took n value here 9, right? 9 plus 1. So, n value will be from 1 to 9. Totally, what will be the answer? 9. Totally, it is 9. Just by substituting the answer option, you will get the value. Only thing here you need to be good is in the value of 10C7, 10C8 and everything. If I take n value as 11, this value is exceeding 100. So, n value, positive integer starts from 1 to 9, I will get the answer. On a new year day, all the members of a youth club decided to send greeting cards to one another. Suppose there are n members in that youth club. Each one sends a greeting card to one another. So, each one will send it to another. Another means n minus 1, right? So, each one will send to 2, one will send to 3, one will send it to n. Like that, total n people are there. N into n minus 1. Total how many cards are there? 9702. 9702. Please don't solve this quadratic equation and show your mathematical intelligence. What you can do is, you can go by the answer option. You can go by the answer option or digital sum. 9702. What is the digital sum? 7 plus 2, 9. 9 plus 9, 18. 18, it is nothing but 9. Answer digital sum should be 9. So, if answer is a digital sum 9, one of the number digital sum should be 9. Answer is 99. 99, 9 plus 9, 18, 1 plus 8, 9. Or you can go by the unit digit. If n is 98, 98 into 97. 8 sevens are 56. Unit digit is 6. But I want to. Second one, 97 into 96. But the digital sum is 7 6 are 42, 4 plus 2, 6. Not possible. Fourth one is 96 into 95. Unit digit itself is not matching. Answer is 99. Do not solve the quadratic equation. Go by the unit digit logic and the digital sum. Go by the unit digit logic and the digital sum logic. You will get these answer very, very quickly. Right? You will get the answer very, very quickly. Next one. If n is an integer between 0 and 13. Of course, if n is greater than 13, 13 minus 4, I will get a negative numbers. Factorial is defined for whole numbers. So, if x is n factorial into 13 minus n factorial. Can I write like this? It is 1 by 1 by n factorial into 13 minus n factorial. I will multiply by 13 factorial numerator and denominator. These nothing but 13 factorial. These nothing but 13cn. 13cn. Are you all with me? Minimum value. If this is minimum, x is minimum. Numerator it is constant. Denominator should be maximum. Denominator should be maximum. When it will be maximum, n is 13 minus 1 by 2 or 13 plus 1 by 2. So, n will be either 6 or 7. Either 6 or 7. So, answer is nothing but 13 factorial by 13c6. So, this is nothing but 13 factorial by 13 factorial by 7 factorial 6 factorial. So, answer for this question is 6 factorial into 7 factorial. 6 factorial into 7 factorial. Very, very easy question if you know the concept. What is the concept? NCR is maximum. NCR is maximum if R equivalent to n minus 1 by 2 or n plus 1 by 2. NCR is maximum only when R equivalent to n minus 1 by 2 or n plus 1 by 2. I multiplied and divided by 13 factorial so that in denominator I will get 13cn. 13cn. NCR is maximum when R equivalent to n minus 1 by 2 or n plus 1 by 2. Next one. This is again an examination question. 52C5. If I is 8, 60 minus 8, which is 52C4. I is 7, 53C4. 53C4. Next is I is 6, 54C4. Next it is I is 5. So it will go on up to which value? I equivalent to 1, 59C4. This is 55C4. Next is 56C4. Next is 57C4. Next it is 58C4. Next it is I equivalent to 8, 52, I equivalent to 1, 59C4. It is 59C4. What is the concept that we discussed at the beginning of the class? NCR plus NCR minus 1. It is nothing but n plus 1 CR. NCR plus NCR minus 1. It is nothing but n plus 1 CR. 52C5 plus 52C4. R value it is 5. So, these is nothing but 53C5. These two combinations. 53C5 plus 53C4. These are nothing but 54C5. 54C5 plus 54C4. These are nothing but 55C5. 55C5 plus 55C4. These are nothing but 56C5. 56C5 plus 56C4. These are nothing but 57C5. 57C5 plus 57C4. These are nothing but 58C5. 58C5 plus 58C4, which is nothing but 59C5 plus 59C4, which is nothing but 60C5. Recursive application of this concept. Answer for this question is 60C5. NCR plus NCR minus 1. It is given by N plus 1 CR. It is given by N plus 1 CR. I hope the idea it is clear. Next one. The value of the expression NCN plus N plus 1 CN, N plus 2 CN and so on up to N plus R CN. Question contains variables. Question contains variables. Answer also contains variables. Answer also contains variables. So what you do is, the best method is substitution method. If the question contains variables, answer contains variables, do the substitution method. Let me take n value 3. If I take n value 3, these 3C3. 3 plus 1, it is nothing but 4C3. 3 plus 2, it is nothing but 5C3. That means I kept n value equivalent to 3 and R value equivalent to 2. R value equivalent to 2. 3C3, out of 3 selecting 3, one way. Out of 4 selecting 3, rejecting 1, 4C1. 5C3, it is nothing but out of 5 selecting 2. It is nothing but rejecting 3. These is nothing but 10 plus 5. Answer is nothing but 15. Answer is nothing but 15. Answer when substitution, I should get answer 15. First one, 15 is an odd number. 2 power it is an even number. 2 power it is an even number. N plus R plus 1. So 3 plus 2 plus 1. It is C2. These is nothing but 6C2. 6C2 is 6 into 5 by 2. Answer is nothing but 15. Option answer for this question is N plus R plus 1 CR. Whenever the question contains variables, answer also contains variables. The best way to solve this question is by using substitution method. Question contains variables, answer contains variables. It is nothing but substitution method. Substitution method. If n minus 1 CR, n minus 1 C4 plus n minus 1 C5 is less than NC6. What is the concept we discussed? NCR plus NCR minus 1. These is nothing but, it is nothing but n plus 1 CR. So these is nothing but n minus 1 C5 plus n minus 1 C4. n minus 1 C4. It is nothing but n minus 1 plus 1 C5. These is nothing but NC5. So NC5, it is less than NC6. NC5, it is less than NC6. What is the another concept that we discussed? 1 is less than NC6 by NC5. What is the another property we discussed? NCR by NCR minus 1 is N minus R plus 1 by R. NCR by NCR minus 1 is N minus R plus 1 by R. So these is nothing but NC6 by NC5 is nothing but N minus 6 plus 1 by 6, which is nothing but N minus 5 by 6. 1 is less than, property based question, sir. 1 is less than n minus 5 by 6. 6 is less than n minus 5. N is greater than 11. What is the least positive integer greater than 11? Answer is nothing but 12. Answer for this question is nothing but 12. NCR by, these are the two important concepts. NCR by NCR minus 1 is n minus R plus 1 by R. NCR plus NCR minus 1 is n plus 1 CR. If you know these two properties, you can solve the question very easily. This is one way of solving the question using properties. It is nothing but using properties. Another is substitute the values and check which is satisfying the question. Which is satisfying the question. I hope the idea it is clear. Next one. Write arrangement based questions. Next one, arrangement based questions. The number of ways in which 6 boys and 5 girls sit in a row. So if they want to sit in a row, Total how many people are there? Total 6 boys and 5 girls. 6 boys and 5 girls can arrange among themselves. Total 11 people are there. 11 people can sit in a row. In how many ways? 11 factorial. Answer is nothing but 11 factorial. Second question. The number of ways in which 6 boys and 5 girls can sit in a row such that all the girls sit together. There are total 6 boys. There are total 6 boys are there and 5 girls are there. And 5 girls are there. All the girls sit together. So make it into one basket. 1, 2, 3 till 6. And that is 1 unit. 7 can be arranged in 7 factorial. These 5 girls can sit among themselves in 5 factorial. Answer is 7 factorial into 5 factorial. 7 factorial into 5 factorial. I hope the idea it is clear. All the girls are sitting together. So I made them sit together and I tied them and I kept them in under one roof. So total there are 7 people are there. 7 people can arrange among themselves in 7 factorial. 5 girls can arrange among themselves in 5 factorial. Number of ways in which 6 boys and 5 girls can sit in a row such that no 2 girls sit together. These are nothing but total ways. Or no 2 girls sit together, right? So if no 2 girls are sitting together, now see here. No 2 girls. First arrange boys. B1, B2, B3, B4, B5 and B6. No 2 girls sit together. First I will arrange boys. 6 boys can sit in 6 factorial ways. They should not sit together. That means there are some spaces. There are some spaces. How many spaces are there? 1, 2, 3, 4, 5, 6, 7. 7 spaces are there. In that 7 spaces, I can arrange 5 girls. 6 factorial into 7p5. Answer for this question is 6 factorial into 7p5. First I arranged all the boys. First I arranged all the boys. After arranging all the boys, there are 7 gaps are there. In that 7 gaps, I will make these 5 girls sit. So 7 gaps are there, 5 girls. Answer is nothing but 6 factorial into 7p5. 6 factorial into 7p5. The number of ways in which 6 boys and 5 girls can sit in a row such that all the girls are not together. All the girls are not together. All the girls are not together. It is nothing but. These nothing but total ways equivalent to. Total ways equivalent to. No girl together. No girls are together. Plus 2 girls are together. Plus 3 girls are together. Plus 4 girls are together. Plus 5 girls are together. Am I right? These are the, all the girls are not together. So these are nothing but total ways. Total ways minus girls together. Please write down, sir. All the girls are not together. Right? All the girls are not together. So, or otherwise you can also do it is like this, sir. Now see here. All the girls are not together. So, these are nothing but G1, G2, G3, G4, G5. 1, 2, 3, 4, 5, 6. So, these are nothing but, if you observe closely, so if first I will arrange boys because no girls are together, right? B1, B2, B3, B4, B5, B6. 6 boys can be arranged among themselves in 6 factorial. Girls are not together. All the girls are not together. All the girls are not together. 7 spaces are there. So, answer is 6 factorial into 7p5. What is the difference between this question and no 2 girls sit together? So, girls are sitting. Okay. This I solved it. 1 minute, sir. Such that all the girls are not together. If all the girls are not together, now 1 minute, sir. So, these are nothing but Or total ways, can I do that? Total ways 11 factorial minus, all the girls are together, 11 factorial minus 7 factorial into 5 factorial. What is this case? This is nothing but the total ways where boys and girls can sit together. These is nothing but the girls are together. Girls are together. 11 factorial minus 7 factorial into 5 factorial. This is the answer for this question. All the girls are not together is total ways minus all the girls are together. If all the girls are together, 6 boys and 5 girls. These 5 girls tie it 6 plus 1, 7. 7 factorial. 5 can be arranged in 5 factorial. Answer for this question is 11 factorial minus 7 factorial into 5 factorial. I think previous question same options are written here. I hope it is clear. The number of ways in which 6 boys and 5 girls can sit in a row alternatively. Alternatively means either boy or girl or girls or boys. So these nothing but 6 factorial into 5 factorial. 6 factorial into 5 factorial. Either you can start with girls 1, 2, 3, 4, 5. All girls can sit together in 5 factorial. Now boys 1, 2, 3, 4, 5, 6. Boys can sit together in 6 factorial. Boys can sit together in 6 factorial. So first you can arrange girls, then boys. They need to sit alternatively. These are nothing but girls. G1, G2, G3, G4, G5. So 5 girls can arrange among themselves in 5 factorial. Remaining 6 boys are there. They can arrange among themselves in 6 factorial. I hope it is clear. 5 factorial into 6 factorial. Boys and girls can be together. Boys and girls are sitting in a row alternatively, one after the other. Or you can take boys as a point of reference. Answer will not change. 6 boys and 6 girls. 6 boys can arrange among themselves in 6 factorial. 6 girls can arrange among themselves in 6 factorial. Both are identical. They both can interchange each other. So answer is 2 boys, it is 2 factorial into 6 factorial into 6 factorial. I hope it is clear. So 6 boys can arrange among themselves in 6 factorial. 6 girls can arrange among themselves in 6 factorial. Both of them can be interchanged. So it is 2 factorial into 6 factorial into 6 factorial. I hope the idea it is clear, right? Suppose if the question is 8 boys and 6 girls. 8 boys and 6 girls. What will be the answer? If it is 8 boys, B1, B2, B3, B4, B5, B6, B7, B8. Now 6 girls are there. 1, 2, 3, 4, 5, 6. 6. Here there are no girls are there. Here there are no girls are there. Right? That means what will be the answer for this question? 0. That means if there are m boys are there. If there are m boys are there. And there are n girls are there. N girls are there. So if m equivalent to n, what will be the answer? 2 into m factorial into n factorial, right? Or if m minus n difference is 1, difference if it is 1, these m factorial into n factorial. If m minus n difference is greater than 1, then the answer is 0 arrangement. 0 ways. Please make a note of it, sir. If there are m boys and n girls sitting in a row, if m equivalent to n, both of them can be arranged one after the other, 2 into m factorial into n factorial. 4 boys, 4 girls. 4 boys can arrange among themselves in 4 factorial. Between 4 boys, B1, B2, B3, B4. Girls can come G1, G2, G3, G4. Are you all with me? And they both can be interchanged also. So it is 2 into m factorial into n factorial. Please make a note of these important key points, sir. If there are m boys and n girls, if m equivalent to n, answer is 2 into m factorial into n factorial. If the difference is 1, then it is m factorial into n factorial. Difference is greater than 1. Girls cannot be arranged between two boys. So answer is 0. Answer is nothing but 0. Very, very important question. Number of ways of arranging all the letters of the word assassination. A, how many times it is present? 1 time, second time, third time. A is present 3 times. S, how many times it is present? 1, 2, 3, 4. 4 times it is present. Next one. I, how many times it is present? I once, I twice. 2 times it is present. Next one. N, how many times it is present? N and N. It is 2 times it is present. 4 plus 3, 7. 7 plus 2, 9. 9 plus 2, 11. So, T it is present once. O is also present once. So, 13 letters can be arranged in 13 factorial. 3 A's are identical. 4 S's are identical. 2 I's are identical. 2 N's are identical. So, answer is 13 factorial by 3 factorial, 4 factorial, 2 factorial into 2 factorial. What is important is not these questions, sir. Please listen carefully to the next question. I hope it is clear. Identical means divide by 3 factorial, 4 factorial, 2 factorial and 2 factorial. This is an exam model question. There is a chessboard. There is a chessboard. The chessboard is like this. A person is there at point A. A person is there at point B. No backtracking allowed. No backtracking allowed. He cannot go back. No backtracking allowed. Only 2 paths are allowed. That means either he can go like this or he can go like this. Only horizontal and vertical movement it is possible. Only horizontal. This is not possible. Up is also not possible. Right to left is not possible. Bottom to top it is not possible. So answer is total how many ways exist. Total how many ways exist. By using these condition, a person can travel from A to B. A person can travel from A to B. Now listen carefully. Suppose he is there at point A. He has to reach point B. Left to right is allowed. Top to bottom is allowed. Right to left not allowed. Bottom to top not allowed. Now see. One way it is horizontal, 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 horizontal. He reached here. Right? Vertical, 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 vertical. That means 4 horizontal and 5 vertical. Can I say that H, 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 V, 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 V. This is one way to reach the destination from A to B. Let me change the position. 2 horizontal, 3 vertical, again 2 horizontal, again 2 vertical. Let me check whether he is reaching the destination. 2 horizontal, 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 vertical, 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 horizontal, horizontal, vertical, vertical. He is also reaching it. That means all the possible arrangements of this way, I will get the answer. Totally how many are there? 9. 9 factorial by 9 factorial by 4 horizontal, identical, 5 vertical, identical. So answer is nothing but 9C4. Answer is nothing but 9C4. It is a very simple way to do. 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 9, I require 4 horizontal. Out of 9, I require 4 horizontal. Or out of 9, I require 5 vertical. So either it is 9C4 or 9C. Either it is 9C4 or 9C5. I hope the idea it is clear. Either it is 9C4 or 9C5. Let me take one more question. One more question. Just by looking at a question itself, you can tell the answer if you can understand How many horizontal, how many vertical he has to go? How many vertical he has to go? He is there at point number A. He is there at point number B. Point number A and point number B. So, in how many ways can he go from A to B? Left to right it is possible. Left to right it is possible. Top to bottom it is possible. After reaching a point he cannot backtrack. No backtracking it is allowed. No backtracking it is allowed. So totally how many are there? 1, 2, 3, 4, 5, 6, 7, 8. Here 8 are there. Here 1, 2, 3, 4, 5, 6, 7. So 8 horizontal are there and 7 vertical are there. So what will be the answer? 15 factorial by 7 factorial into 8 factorial. This is given in the form of an letters word, and the same can also be represented in the form of a diagram. So 8 horizontal, 7 vertical. Total arrangements are 15 factorial. Horizontal 8 are identical, 7 vertical it is identical. So 15 factorial by 7 factorial into 8 factorial. Next one, Banaras. B, how many are there? 1. A, how many are there? 3 are there. N, how many are there? 1. R, how many are there? 1. S, how many are there? 1. So totally 7 letters are there. So it is nothing but 7 factorial by 3 factorial. 7 factorial by 3 factorial. 7 is a prime number. Answer should be divisible by 7. Not possible. Not possible. Not possible. Or you can go by the calculation, which is 7 into 6 into 5 into 3 factorial divided by 3 factorial. 20. Answer is nothing but 840. Answer is nothing but 840. You don't need to do all this. 7 is a prime number. Answer should be divisible by 7. Answer should be divisible by 7. The number of arrangement of the letters of the word banana. The arrangement of the letters of the word banana, in which the two N's appear consecutive adjacently. So 2 N's pack it up. If I pack it up, A, here it will be N and N. These pack it up. 1, 2, 3, 4, 5. 5 letters can be arranged in 5 factorial. A 3 times it is identical. 3 times it is identical. These 2 N can be arranged among themselves in 2 factorial. 5 factorial by 3 factorial into 2 factorial. I hope it is clear. 2 N's are appear adjacently. So if they appear adjacently, and I will pack it. So total 5 can be arranged in 5 factorial. A is 3 factorial. That 2 N's can arrange among themselves in 2 factorial. So these are nothing but banana. The number of arrangement of the letters of the word. 2 N's do not appear adjacently. These are nothing but the total arrangement. Total arrangement minus total arrangement minus total arrangement where the N's appear adjacently. Before that we solved it. N appear adjacently. Total previous question answer and the just previous question answer. Subtract it, you will get the answer. Subtract it, you will get the answer. Now, till now we did with respect to arrangement of alphabets. Now we will do arrangement of digits. Listen carefully, sir. Digits. Number of 4-digit numbers formed. Total there is a 4-digit number formed by using the digits. 0, 1, 2, 3, 4, 5. Total 6 digits are there. Repetitions are allowed. Here repetitions are allowed. So 0 cannot come because it's a 4-digit number. So here 1, 2, 3, 4, 5. Any 5 will come. Here repetition is allowed. So 0 to 5. Here repetition is allowed. 0 to 5. Here repetition is allowed. 0 to 5. 1, 2, 3, 4, 5. 5 cases into 6 cube. Answer is nothing but 5 into 6 cube. Answer for this question is 5 into 6 cube. Why? Because the leftmost 0 cannot come. 1 can come, 2 can come, 3 can come, 4 can come, 5 can come. So 5 into 6 cube. 5 into 6 cube. Next one, number of 5-digit numbers. I want a 5-digit numbers. What are all the digits which are there? 0, 1, 2, 3, 4. The number of numbers in which at least one digit is repeated. At least one. At least one is nothing but. At least one digit is repeated. At least one digit is repeated, it is nothing but. At least one digit is repeated, it is nothing but. Total number of numbers. Total number of numbers minus numbers where no digit is repeated. Minus numbers where no digit is repeated. Total numbers means repetition is allowed. Minus numbers where no digit is repeated. I hope it is clear. Now I require a 5-digit number. Here 1, 2, 3, 4. 4 digits can come. Here 0 to 4 can come. Here 0 to 4 can come. Here 0 to 4 can come. These is nothing but 4 into 5 cube, which is nothing but 4 into 5 cube. These are the total numbers that can be formed with repetition allowed. Minus numbers where no digit is repeated. No digit repeated. Oh, it is 5-digit number, right? So next one can also be 0 to 4. So it is 5 into 4 into 5 power 4. 4 into 5 power 4. It is a 5-digit number where no digit is repeated. That means here 1 to 4 will come. Total 5 digits. 1 digit is fixed. Here 4 digits will come. Remaining 3 digits will come. Remaining 2 digits will come. Remaining 1 digit will come. So 4 into 3 into 2. 4 into 4 into 3 into 2. These are nothing but 625 into 4 minus 16 6 are 96. 16 6 are 96. 5 4s are 20. 0 minus 6. Carry it is nothing but 4. Answer is nothing but 2404. Answer is nothing but 2404. Totally it is a 5-digit number. Leftmost cannot take 0. If the leftmost cannot take 0, it can take 1, 2, 3, 4, 4 digits. 0 to 4, 0 to 4, 0 to 4, 0 to 4. 5 power 4 into 4. Total numbers are 5 power 4 into 4. Numbers where no digit is repeated. Leftmost 1, 2, 3, 4. Out of 5 digits, leftmost 1 digit is written. Remaining 4 digits. Out of 5 digits, 2 digits are written. Remaining 3 digits. Remaining 2 digits, remaining 1 digit. 4 into 4 into 3 into 2 into 1. Which is 96. Or you can use a digital sum concept. If I use a digital sum, 6 plus 2, 8, 8 plus 5, 13. 13 is 4. 4 4s are 16. 16 is 7. Minus 96 digital sum is 6. 7 minus 6 it is 1. 4 plus 4, 8. 8 plus 2, 10. 10 digital sum is 1. 10 digital sum is 1. I hope the idea it is clear. You can either go by the digital sum or go by the unit digit logic. Next question. Number of 5-digit numbers. Okay. I want 5-digit numbers. I want 5-digit numbers that contain 5 exactly ones. If 5 is present in the units place, here 0 cannot come. Here 5 cannot come. Here 1 to 9, any number can come. Here 1 to 9, any number can come. Total 0 to 9, 10 digits are there. 0 cannot come, 5 cannot come. So it is nothing but 8. Here 0 to 9, 5 can come exactly once, 5 cannot come. So here it is nothing but 9. Here also 0 to 9, 5 cannot come. 0 to 9, 10 digits. 5 cannot come into 9. Here also 0 to 9. 5 cannot come. So here it is nothing but 8 into 9 into 9. These 5 can be there in 5 can be there in units place, the same pattern. 5 can be there in tens place. 5 can be there in hundreds place. 5 can be there in thousands place. 5 can be there in thousands place. So 5 can shift from units, tens, hundreds, thousands. So here it is nothing but 8 into 9 cube into 4. 8 into 9 cube into 4. 4 means 5 is in units, tens, hundreds and thousands. Again it is a 5-digit number. If the leftmost it is 5. 0 to 9. 5 cannot come. Are you all with me? 0 to 9. 5 cannot come. 0 to 9. 5 cannot come. 0 to 9. 5 cannot come. 0 to 9, 10. So it is nothing but 9 power 4, which is 9 into 9 cube. 9 into 9 cube. 5 can be there in exactly 1 means units place, tens place, hundreds place, thousands place, or the leftmost place. 32 into 9 cube plus 9 into 9 cube. What will be the answer for the question? 41 into 9 cube. Answer for this question is nothing but 41 into 9 cube. 41 into 9 cube. I hope the idea it is clear. Most of the problems whatever we are solving today, either they are from the property based or they are from the previous year exam questions. The number of 4-digit numbers, number of 4-digit numbers that contain digit 9, it is a 4-digit number. So 9 can be there in the units place. Here 0 to 0 cannot come. 0 cannot come. So it can take any value from 1 to 9. So it is nothing but 9. Here 0 to 9. Here it is 0 to 9. 0 to 9. That contain digit 9. Now see here. So these nothing but these 9 into 10 into 10. 9 into 10 into 10. 9 can be there in units place, tens place, hundreds place. So it is into 3. If 9 is present in the leftmost place, here it is 0 to 9. Here it is 0 to 9. Here it is 0 to 9. These nothing but 1000. So here it is 27. What is these 2700 plus 100? 9 is present at least once I did it. At least once. Now we will do only once. That contain digit 9 only once. Let us do only once. If I do only once, it is a 4-digit number. 9 is there in the units place. 0 cannot come. 9 cannot come. 0 to 9, 10. 0, these nothing but 8 ways. Here 9 cannot come. So it is nothing but 9 ways. Here 9 cannot come. Here it is nothing but 9 ways. 8 into 9 into 9. 9 can be there in units place, tens place and hundreds place. If 9 is there in the leftmost place, 9 cannot come. So here it is nothing but 9 ways. 9 cannot come, 9 ways. 9 cannot come, 9 ways. It is nothing but 9 into 9 into 9. 9 into 9, if I take common, 9 nines are 81. 81 into 24 plus 9. 24 plus 9. So answer is nothing but 81 into 24, 81 into 9. 81 into 33. Whatever the answer that you get, that itself is the answer. What is that question we did? Number of 4-digit numbers that contain digit only once. What is the previous question we did it? Number of 5-digit numbers that contain 5 exactly once. Next question. Number of 4-digit even numbers. 4-digit even numbers. Even numbers means Unit digit can be 2, 4 or 6. Unit digit can be 2, 4 or 6. So totally how many digits are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Out of 6, 1 digit it is fixed. Remaining 5 digits will come. Remaining 4 digits will come. Remaining 3 digits will come. These 3 digits, either 2 or 4 or 6. So into 3. These are nothing but 20 into 9. Answer is nothing but 180. Answer is nothing but 180. Because it's an even number, unit digit has to be an even number. It can be either 2 or 4 or 6 from the given set. Out of 6 digit number, 1 unit digit it is fixed. Leftmost it can take any one out of the 5. Next it can take 4. Next it can take 3. So 5 into 4 into 3. 2, 4, 6. There are 3 cases. 20 into 9. 180. Next one. Number of, these are all previous year examination questions, sir. Number of 4 digit even numbers. 4 digit even numbers. First I will fix 0. If I fix 0, then I will fix either 2 or 4. Separate cases I will get, because the leftmost cannot be 0. If the unit digit is 0, here 0 cannot come. Here no digit is repeated, right? So from 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Total 6 digits are there. 0 it is fixed. So 5 digits will come. Out of 6 digits, 2 digits are fixed. 4 will come. And here 3 will come. There are 16 numbers, even numbers, which will end with 0. If it is 2, leftmost cannot be 0. Leftmost cannot be 2. Are you all with me? Leftmost, because the digit repetition is not allowed. Leftmost cannot be 0, cannot be 2. If it is, totally how many digits are there? 6 digits are there. 6 digits are there. 0 cannot come, 2 cannot come. So which all places can come? 1 can come, 3 can come, 4 can come, 5 can come. Here 4 places will come. Out of 6 digits, leftmost is fixed, rightmost is fixed. Remaining 4 digits will come. Remaining 3 digits will come. So here it is nothing but 4 into 4 into 3. Either 2 or 4. 2 cases will come. These are nothing but 16 6 are 96. 60 and 96. Answer is nothing but 156. 60 and 96, answer is nothing but 156. All are exam model questions. Watch the class entirely, then only you will get a perfect understanding of every possible question. Again, second time I am repeating, unit digit is 0. If the unit digit is 0, leftmost cannot be 0. If the leftmost cannot be 0, it can take any one out of the 5 digits. 1, 2, 3, 4, 5. Therefore, it is 5 cases. Out of 6 digits, leftmost is fixed, rightmost is fixed. Remaining 4, remaining 3. 5 into 4 into 3, answer is 60. If the unit digit is other than 0, 2. If it is 2, leftmost cannot be 2. Leftmost cannot be 0. 2 is out, 0 is out. Remaining 4 digits are there. So any one out of the 4 will come, 4. Out of 6 digits, leftmost is fixed, rightmost is fixed. Remaining 4, remaining 3. Either unit digit can be 0 or the unit digit can be 2 or 4. 60 plus 96. Answer is nothing but 156. Next one. Number of 4 digit even numbers. Number of 4 digit even numbers where the repetition of the digits is allowed. So unit digit can be either 2 or 4 or 6. Here there is no 0. So it can come from 1 to 6. It can come from 1 to 6. It can come from 1 to 6. 6 into 6 into 6 into 3. These is nothing but 216 into 3. Answer for this question is nothing but 648. Repetition of the digits is allowed and there is no 0. So it's a very easy question. This is a very, very easy question. Answer is 216 into 3. Next one. Number of 4 digit even numbers. Even numbers means, suppose here 0, here 2 or 4. The difference is, previous questions repetition not allowed, now the repetition is allowed. Here 1, 2, 3, 4, 5. Any number can come. Here the repetition is allowed 0 to 5. Here the repetition is allowed 0 to 5. If it is 2, here 0 cannot come. Here 1 can come, 3 can come, 4 can come, 5 can come. 0, 1, 2, 3, 4, 5. Here from 0 to 5 can come. Here from 0 to 5 will come. With unit digit 0, how many cases are there? 5 into 6 into 6. Or plus. With 2, how many cases are there? 4 into 6 into 6 into 2. 6 into 6 if I take common, which is 36, into 5 plus 4 2s are 8. 36 into 13. 36 into, somewhere I think we did a mistake. So these is nothing but, here 2 can come, right? Repetition is allowed. 2 can come. So it is nothing but 5. These is nothing but 5. I hope it is clear, right? Repetition is allowed. Similarly, 4 means 5. So 6 into 6 common. These is nothing but 36 into, 1 minute. Let me erase it. So these is nothing but 5 into 6 into 6. 5 into 6 into 6 is 36. 5s are 180. These nothing but 36 5s are 180. 36 10s are 360. 360 plus 180. Answer is nothing but 540. Very, very easy question. Do it slowly, sir. Do it slowly. All these number related problems are extremely important to you. Just be little careful and try to solve. Number of 4 digit numbers. It is a 4 digit number formed with the digits. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The no digit is being repeated. Repetition of the digits is not allowed. Repetition of the digits is not allowed. Okay. These also clear. Repetition of the digits is not allowed. Which are divisible by 5. If it is divisible by 5, unit digit has to be 5. For a number to be divisible by 5, unit digit should be 0 or 5. 0, it is not there. So repetition, it is not allowed. So 5 will not come here. So it is 1, 2, 3, 4 and it is 6. So total 5 digits can come here. Out of 6 digits, 1 to 6, 6 digits. Leftmost is fixed, rightmost it is fixed. 4 digits are remaining. 4 into 3. So 23s are. Answer for this question is nothing but 60. 5 into 4 into 3. Answer is nothing but 60. Idea it is clear. Now I will include 0. Number of 4 digit numbers. Number of 4 digit numbers formed with the digits 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Repetition of the digits is not allowed, which are divisible by 5. If it is divisible by 5, either unit digit can be 0. Either unit digit can be 0 or the unit digit can be 5. Either the unit digit is 0 or the unit digit is 5. If 0 is there, here 0 cannot come. So here 1, 2, 3, 4, 5. 5 digits can come. So here it is 5 ways. Now digits are not repeated. 6 digits are there. Leftmost and rightmost it is fixed. Remaining 4 digits remaining 3 digits. So these nothing but 60. 60 is the case where the unit digit is 0. If the unit digit is 5, if the unit digit is 5, here 5 cannot come. Here 0 also cannot come. So 5 and 0 cannot come. Here 1, 2, 3, 4. 1, 2, 3, 4. 4 digits can come. Out of 6 digits, leftmost and rightmost it is fixed. Remaining it is 4. 4 into 3. 4 into 3. So these are nothing but 16 3s are 48. 60 plus 48, it is nothing but 108. 60 plus 48, it is nothing but 108. Very, very important. Once this class is uploaded, watch the entire class again and again, sir. So that not a single variety of question that comes in permutation and combination, we will miss it out in my video lectures. That is the reason every chapter I give it very comprehensively. Number of 4-digit numbers which are divisible by 5. So it is 5. So this can be from 1 to 6. This can be from 1 to 6. This can be from 1 to 6, which is 6 into 6 into 6 into 5. 6 into 6 into 5. 5 is fixed. So it is into 1. 6 cube. Answer is nothing but 216. Answer is nothing but 216. I hope the idea it is clear. Number of 4-digit numbers which are divisible by 5. Just now we did. Answer is 216. Repetition allowed with if it is 0. If this is 0, here 0 cannot come because it's a 4-digit number. Here 1 to 5, any number can come. Here 0 to 5 and here 0 to 5. Repetition is allowed. So here it is 5 into 6 into 6. 36 5s are 180. This is where the unit digit is 0. If the unit digit is 5, repetition it is allowed. So here it is 0 to 5. Here it is 0 to 5. Here only 0 cannot come. So here it can be 1 to 5. These are nothing but 5 into 6 into 6. 36 5s are 180. Either the unit digit can be 0 or the unit digit can be 5. 180 plus 180. Answer for this question is nothing but 360. Answer is nothing but 360. I hope it is clear. Next, another variety of question. Till here, any doubts are there? Kindly reply it in the live chat. Any doubts? Kindly reply. Next, another variety of questions based on digits. Repetition is not allowed. Number of numbers consisting of 5 digits. This is a 5 digits. And they are divisible by 4. Divisible by 4 means last 2 digits should be divisible by 4. Last 2 digits should be divisible by 4. Last 2 digits divisible by 4. 12 it is divisible by 4. 12, 13 not divisible, 14 not divisible, 15 not divisible, 16 it is divisible by 4, 21 not divisible, repetition is not allowed, 24 it is divisible, 26 not divisible, 32 it is divisible, 36 it is divisible, 41, 42, 43, 44, 44 repetition allowed, 45, 46. 51, 52, another one. 53, 54, 55, 56, another one. Next one. 60, 61, 62, 63, 64. 64. So, last 2 digits are divisible by 4. 1, 2, 3, 4, 5, 6, 7, 8. So, out of total how many digits are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 digits are fixed. So, remaining 4 digits, any 4 digits will come. Any 3 digits will come. Any 2 digits will come. 4 into 3 into 2. So, these are the ways of forming the leftmost 3 digits. So, 4 into 3 into 2. Like that, how many cases are there? 1, 2, 3, 4, 5, 6, 7, 8. These are nothing but 12 into 16. 12 into 16, answer is nothing but 192. Answer for this question, it is nothing but 192. It can be 12, it can be 16, it can be 24, it can be 32, it can be 36, it can be 52, 56. Repetition not allowed, so 44 it is not taken. I hope it is clear. Answer is 192. Next one, if the repetitions are not allowed, repetition of the digits is not allowed, the number of numbers consisting of 5 digits, it is 5 digits. Divisible by 4. Divisible by 4 means last 2 digits should be divisible by 4. Last 2 digits should be divisible by 4. If last 2 digits, if it is divisible by 4, 04, it is divisible by 4. 01, 02, 03, 04, 05. With 1, 12, it is divisible by 4. 10, 12, 13, 14, 15. Next 2, 20. It is divisible by 4. 20, 21, 23, 24. 24, it is divisible by 4. 25. 30, 31, 32. It is divisible by 4. 34, 35. Next is 40. It is divisible by 4. 41, 42, 43. 44 repetition allowed. 50, 51, 52. 52, 53, 54, 55. These are the possible cases. How many cases we got? 1, 2, 3, 4, 5, 6, 7. 7 cases we got. Answer should be divisible by 7. These 7, 144, it is not divisible. 7 2s are 14, 22. It is not divisible. 7 2s are, now, is there any other case that we missed it out? Let us see. 104 with 0. With 0. 04, it is divisible by 4. 01 not possible. Repetition not allowed, right? So 00 we cannot consider. 04, right? Next one 12 we have taken. Next one 20. 24 also we have taken. Next one 30. 32 we have taken. Next one 40, 41, 42, 43, 44, 45. Next one 50, 50, 51, 52, 52. Repetition is not allowed. Total how many digits are there? 3 plus 3, 6. 2 digits are fixed. So these nothing but 4 into. These can take any of the 4. Any of the 4. Out of how many digits are there? 6 digits are there. 2 digits are fixed. Remaining 4. 3 digits are fixed. Remaining 3. I hope it is clear. Here 2 digits it is there. Here any one out of the 4 digits will come. 3 digits are fixed. Again remaining 3 will come. Again 2 will come. So answer is 4 into 3 into 2 into 7. So these are nothing but 4 3s are 12, 12 2s are 24, 24 7s are 8. I think one case it is missing, sir. What is that case? Let us see. One case we are missing. One case we are missing. What is that case? Let us see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These are nothing but 1, 2. These are nothing but 1, 6. Next one. 21 not divisible by 4. 24 it is divisible by 4. 25, 26. 31, 32. 31, 32. 36 also it is divisible. 41 not divisible. 42 not divisible. 43 not divisible. 44 not divisible. What is the case that we have not taken? Right? What is that case that we have not taken? Let us do it slowly. This is the counting problem, right? We have to be very, very careful. This is 5-digit numbers. Which all digits are there? 1, 2, 3, 4, 5, 6. What is the concept? Last 2 digits should be divisible by 4. Last 2 digits should be divisible by 4. Last 2 digits, which all cases? 1 is 12. Let us go slowly. 12, 13, 14, 15, 16. 16 it is divisible. 21, 23, 24, 24 it is divisible. 25, 26, 31, 32 it is divisible. 33, 34, 35, 36, 36 it is divisible. 3 over. 41, 42, 43, 44 not possible. 45, 46 not possible. 51, next it is 52, 53, 54, 55, 56. It is also possible. Right? Next one, 61, 62, 63, 64, 64 it is possible. So here it is nothing but out of 6 digits, 1, 2, 3, 4, 5, 6, 2 digits are fixed. This can come in 4 ways. 3 digits are fixed. This can come in 3 ways. This can come in 2 ways. 1, 2, 3, 4, 5, 6, 7, 8. 4 into 3 into 2 into 8. 16 3s are 48. 48 4s are 192. Answer for this question is nothing but 192. I hope the idea is clear. Be careful with respect to counting, sir. Be careful with respect to counting. Next one.